So, in last class we are discussing about that spherical wave propagation. Okay. So, we are saying that instead of linear wave, sound is propagated like a spherical sphere. So, I can say that this is the source of the sound and it is propagated like a sphere. So, instead of linearly propagate, it propagated in all direction, in all 3-dimensional space, in all direction like a sphere, spherical wave propagation. Now, what is the difference? Now, I know that in Cartesian coordinate x, y, z we have considered. Now, in here I have to convert that x, y, z to r, theta and phi. Okay. Same 3 coordinate, instead of x, y, z I convert that r, theta and phi. So, in that case what we will do? We just draw the coordinate x, y, z and we put a point here which is r. So, if this point is theta, so this is r, projection of r here is r cos theta. Now, if I make a projection in xy plane of this same r, I get r sin theta. So, the projection of r sin theta on x axis give me the x. So, x is, so I can write x is nothing but a r sin theta cos phi if this angle is phi. Okay. Similarly, y is nothing but a r sin theta sin phi and z is nothing but a r cos theta. Okay. Z is nothing but a r cos theta. So, we know what is the wave equation? We know the wave equation is nothing but a divergence square of p is equal to 1 by c square del square p by del t square. Okay. This is the linear wave equation. So, I can say that what is the meaning of this thing? This is nothing but a del square by del x square plus del square by del y square plus del square by del z square. Okay. So, this is that things. Now, instead of x, y, z, this term can be calculated from this x, del x, del x, del x, del square del x square I can calculate, del square del y square I can calculate and del square del z square I can calculate. So, eventually this Laplacian operator will become in theta, r and phi domain, that will be del square by del r square first term plus 2 by r del by del r plus 1 by r square sin theta into del by del theta into sin theta del theta plus 1 by r square sin square theta into del square by del phi square. So, this is proof of this thing, this is a details mathematical proof you can calculate in that case. So, now if this is the case, so instead of this I have to get this whole equation. Okay. Now, think, I said sound is propagated or acoustic wave is propagated in a spherical in nature. So, in every angle, every direction it is symmetric. If something is propagated in spherical nature, that means I am saying it propagated in symmetric in all direction. So, if it is propagated symmetric in all direction, so the variation against the theta and phi will be not consider, nothing will be there. So, I can say the variation against the theta and phi, no terminology will be there. So, I can say this whole terminology will be vanished. If I write del square p, then it will be only del square p by del r square plus 2 by r del p by del r. Okay. So, del square p by del r square plus 2 by r del p by del r. Now, if I say this term can be written as 1 by r del square r p divided by del r square. I can prove it. Let us write 1 by r del square rp divided by del r square. What is this? It is nothing but a 1 by r del by del r into r del p by del r plus p. Then I took that things also. So, 1 by r into r del square p by del r square plus del p by del r plus del p by del r 1 by r and 1 by r. So, r cancel. So, it is nothing but a del square p by del r square plus 2 by r del p by del r. So, this thing and this thing is same. So, I can write del square p is nothing but a 1 by r del square r p divided by del r square. Okay. So, my acoustics wave equation, I just put this value in here. In case of spherical wave propagation, it becomes 1 by r del square r p divided by del r square is equal to 1 by c square del square p by del d square. Okay. Now, if I say p is my function, the pressure amplitude. So, I said the pressure amplitude, independent pressure amplitude is independent of r. Can I say that? That pressure amplitude p is independent of r. Can I say that? So, if I say that spherical wave propagation also preserve the conservation of energy. So, now let us take a small sphere with a radius, let us r1, and with the intensity of the wave is I. So, energy at this surface of the sphere, if all direction I will be same. So, I multiply by the 4 pi r1 square. Okay. Similarly, if I take another at this distance a sphere whose radius is r2. So, in energy in here is 4 pi r2 square into I. So, now if I say the conservation of the energy let us there is no loss in acoustic wave propagation, consider that there is no other kinds of losses. So, energy in here and energy in here will be the same. So, I into 4 pi r1 square and I into 4 pi r2 square will be the same. Since r1 and r2 is not same, these two term if has to be same, then I has to be changed. So, what is I? I is nothing but a p square by 2 rho 0 c. So, p cannot be a parameter which is independent of r. So, instead of p, I consider rp is a parameter, rp is a pressure amplitude or amplitude which is independent of r. So, instead of p, here I consider rp is the function. So, I can write rp divided by del t square. So, this 1 by r will be not there. So, I can say in case of spherical wave propagation, wave equation become del square rp divided by del r square is equal to 1 by c square del square rp divided by del t square. Okay. So, this is the spherical wave propagation equation. Okay. So, in that case, what is the solution? What is the solution in spherical wave propagation? So, I can say Rp is a consistence of two functions of wave. One is called forward wave, or you can say the converging, and another is called divert or forward means it is going out. So, it is a diverging wave in case of sphere, and if it is backward wave, so it is a converging wave. So I can write, this RP is two function, one is F1 into Ct minus R and plus F2 Ct plus R. So this is a converging wave and this is a diverging wave. So waves are diverted is a forward wave, and when it is a backward wave means wave are converted. So it is a diverging wave and this is a converging wave. Now what is P? P is nothing but a 1 by R, that function F1 plus F2. So now if it is 1 by R, so at R equal to 0, this concept does not valid. Diverging wave, converging wave at R equal to 0, P no solution is valid. So in that case what will happen? So solution fail. So in case of solution fail, for outgoing wave solution fail at origin, because some source of sound is required to supply the energy carried away, but wave equation does not contain any term representing this energy source. So it means that medium must excluded from some volume from the media, some volume must be excluded from the media, from the medium. So that space at origin that space which is acquired by the sound source or acoustic source, that acquired by the acoustic source. Now in case of diverging wave, it is fail. Explanation is that for incoming wave, energy is being focused at origin and the small amplitude approximation will fail. This will manifest itself in a nonlinear wave equation and strong acoustics losses. Okay. So this is the physical meaning of if R equal to 0. Now let's R is not equal to 0 and we proceed. Then I can say, if this is my wave equation, okay, this is the wave equation, then what is the general solution of this wave equation? So general solution is that Rp is equal to A e to the power j omega t minus k. K is the wave constant and R is the distance from the source. Okay. So in that case, P is nothing but A by R e to the power j omega t minus k r. Okay. So this is the P. Now if this is P, what is velocity potential? Phi. So it is written that rho 0 del phi by del t is equal to minus P. Okay. We said the del by del t we always write j omega. So it is rho 0 j omega phi is equal to minus P. So phi is equal to minus P divided by j omega rho 0, velocity potential. Now what is the particle velocity? U is nothing but a divergence of phi. So in case of spherical coordinate, divergence means d phi by dr only, d phi by dr only. So if I put the d phi by dr in case of P, what I will get? Let us put the d phi by dr. So phi is equal to minus P by j omega 0 rho 0. So I can write minus A by R e to the power j omega t minus k r divided by j omega 0 rho 0. Now I take the del phi by del r, del phi by del r. What I will get? First order differential equation. So I will get, I just writing 1 minus j by k r into P by rho 0 c. If you do the differentiation, you will get this thing. Del phi by del r is nothing but a 1 minus j by k r P by rho 0 c, which is nothing but a u. Now see that in case of linear wave equation, that pressure wave P and phi are in the same phase, but here u is a function of some complex thing. So, if I want to calculate the impedance Z, so Z is nothing but a P by U, Z is nothing but a P by U. So, if I calculate the Z, what I will get? So, I will get, so P will be cancelled, P by 1 minus J by K R into P by rho 0 C. So, P cancel. So, it is nothing but a rho 0 C divided by 1 minus J by K R. So, I can write it is nothing but a rho 0 C into K R by K R minus J, K R by K R minus J. Let us consider K R by K R minus J. So, in case of linear wave, Z is nothing but a rho 0 C. Here I am saying there is another complex term is here. Okay. Let us consider this J create an angle. So, if I say if representation of the J, if this is theta, then if I represent this complex number in a trigonometric form, so it will be K R, it will be 1 and it will be root over 1 plus K R square if this angle is theta, if this is K R, this is 1. So, I can write this complex term in term of amplitude and theta, in term of amplitude and theta. So, I can write let us A minus JB, A minus JB. So, I can write root over of A square plus B square is the amplitude and e to the power j theta, and theta will be tan inverse B by A. This will be minus, this will be minus. So, I write minus theta. So, instead of plus theta, I write minus theta, then it will be plus. So, instead of 1 by K R into J, I can write rho C into K R by amplitude 1 plus K R square into e to the power minus j theta, e to the power minus j theta. Same thing I can write rho 0 C K R by root over of 1 plus K R square into e to the power j theta, minus will be plus when it go up. Now, what is K R by 1 plus K R square? So, we have draw that triangle like this way. This is theta, this is 1, this is K R, this is 1 plus K R square. So, what is cos theta? Cos theta is nothing but a base divided by 1 plus K R square. Okay, K R square. Okay. So, in that case, I can write this is nothing but a rho 0 C cos theta into e to the power j theta into e to the power j theta. So, rho 0 C cos theta into e to the power j theta. So, if I say the amplitude part of the Z is not rho 0 C. So, in case of spherical wave propagation, the impedance, acoustic's impedance is not rho 0 C. Instead of rho 0 C, it is a rho 0 C cos theta. What is the theta? Theta is the angle between the pressure and velocity. Theta is the angle between the pressure and velocity. Now, if this is theta, what is theta? I can write cot theta, cot theta is equal to kr by 1. So, cot theta is nothing but a kr. Cot theta is nothing but a kr. Now, what is kr? What is kr? R is the distance from the source. What is k? K is the omega by c. So, I can write kr is nothing but a 2 pi r divided by lambda. 2 pi r divided by lambda. So, I can say that theta is a function, theta is a function of the ratio between the distance from the source and wavelength of the acoustic source, acoustic wave. So, distance from the source and wavelength of the acoustic source. Now, let us the spherical wave is started here and going like this way. If this r is small, very small compared to this lambda, what will happen? If r is very small, so that means the distance travelled by the source, this distance travelled by the acoustic wave from the source is very small compared to the wavelength of that acoustic wave. So, compared to the wavelength of the acoustic wave, if the distance is very small, then the complex, the theta, value of the theta will be large, theta will be increased, theta will be very large. Now, if the distance is very far away, let us from the source, compared to lambda is r is very large, that means the the acoustic wave is travel far away from the source. In that case, theta will be very small because cot theta. So, theta will be very small. So, in that case, theta is very small means angle between the pressure wave and particle velocity or velocity wave will be almost nil. So, in that case, z becomes rho 0, rho 0 c cos 0 1. Okay. So, at the far away from the source, it looks like a plane wave. Although it is a spherical wave, it looks like a plane wave. Okay. Now, I can express z in other term also. So, you have seen that z is a complex function. So, it is a 2 parameter function. So, z is nothing but a rho 0 c cos theta e to the power j theta, cos theta e to the power j theta. Now, what is e to the power j theta? Is nothing but a cos theta plus j sin theta. So, I can write z is nothing but a rho 0 c cos theta into cos theta. So, cos square theta plus rho 0 c cos theta in j sin theta, or I can write rho 0 c cos square theta plus j cos theta sin theta. Okay. So, what is the value of cos theta and sin theta? I said the cos theta is nothing but a kr by root over of 1 plus kr square. So, I can write rho 0 c kr square divided by 1 plus kr square plus j rho 0 c into cos theta kr by 1 plus kr square and sin theta is 1 by root over of 1 plus kr square. So, it is nothing but a 1 by 1 plus kr square. Okay. So, if you see a plus jb, so z is not a resistive, not only the resistive term, there also a some term which is reactance. So, it is called acoustic resistance and it is the acoustics reactance, acoustic resistance and acoustics reactance. For large value of kr, if the kr is very large, if the Kr is very large, then you see this term is 0 and this term is 1. So, it is Z is nothing but a, so at Kr is very large, Z is nothing but a rho 0 C. Now, if the Kr is very small, then Z become 0. So, that cannot be explained, that cannot be explained. So, if the Kr is very small, Z become 0. Okay. Now, okay, that wave equation I have understand. Now, one things, how do we express the intensity of the sound? Most of the cases, most of the sound wave propagation we discuss about the spherical wave propagation. So, now we have to find out what should be the expression of the intensity in case of spherical wave propagation. So, in case of plane wave propagation, I is nothing but a p square by 2 rho c, p square by 2 rho c. I have to say whether this I expression is remain same in case of spherical wave or it is changed. Okay. So, let us I consider that P is nothing but a by r e to the power j omega t minus k r. Okay. And in u is nothing but a p by z, I can write p by z, p by z. So, it is nothing but a by r z, z is the impedance e to the power j omega t minus k r, where z is equal to rho 0 c cos theta e to the power j theta. Okay. So, I can write u is nothing but a by r rho 0 c cos theta e to the power j theta into e to the power j omega t minus k r. So, I can write a by rho 0 c r cos theta into e to the power j omega t minus k r minus theta, e to the power theta I can term into the here. So, minus theta. Okay. Now, this is u and this is p is this. So, what is the real part of the p? If I say the real part of the p, so p real part of the p is nothing but a by r cos omega t minus k r. Okay. Now, what is the real part of u? Real part is nothing but a by rho 0 c cos theta into r, the term will be there, into cos omega t minus k r minus theta, minus k r minus theta. Let this term as a capital U and this term as a capital P. Okay. So, now if that is the case, then I can write P is equal to, so I can write U is equal to small u, so this is the capital U and this is the P is equal to A by R, capital P is equal to A by R and capital U is equal to A by rho 0 c cos theta, rho 0 c cos theta into R. Okay. So, A by R is nothing but a P, capital P by rho 0 c cos theta, R is not there. So, I can write capital P is nothing but a capital U into rho 0 c cos theta. rho 0 c cos theta. Now, what is I? What is intensity of the wave? Intensity of the wave I is nothing but a average intensity, time average 0 to t pressure into velocity. So, what is pressure? Pressure is capital P cos omega t minus kr into capital U cos omega t minus kr minus theta into dt. Okay. Now, do this whole integration. If you do this integration, you will get, what you will get? P into u cos theta divided by 2. P into u cos theta divided by 2. So, if I get that, what is P? P is A by, or I can in term of P or u, any one I can replace the u in term of P. So, u is nothing but a, so P into P by 2 rho 0 c cos theta into cos theta, cos theta, cos theta cancel. So, it is P square by 2 rho 0 c. So, it is the same as linear wave intensity equation. Okay. It is the same as linear wave intensity equation. So, next class I will discuss the physical meaning of acoustic intensity propagation. What is decibel, how decibel is measured, why it is decibel, and why intensity as energy is different, that we will discuss in the next class. Okay? Thank you.